Okay, all right, here we go. So today, we're gonna spend one last day on the laws of exponents before we go on to the functions, exponential function starting tomorrow. Okay, so yeah, I'm gonna show you the toughest questions you will see at your grade level, and then we'll practice. Okay, all right. All right. Okay. So before we even start, hopefully I can avoid some of the announcements. On the what is that, the PA, is that right? Public announcements, and also finish this before the day starts. Okay, so yesterday we had done a good amount of exponents, right, with the laws of exponents. So today, I am going to, this just occurred to me, maybe I should give everyone a handout on all the rules. All right, I gotta write that down. Hold on. Okay, all right. And as I'm doing this, I'm also thinking, sometimes, with this year, with the lack of time that we had for class and for really everything, it made me think that it's a little bit too extravagant to spend all this time going over. It's like spend 4 days going over the rules of exponents. But I also really believe that if you, what? Like, it's very hard for me as your teacher to justify that, that like you're a product of a free universal education without you knowing how to operate with exponents, just like equations in general. I think that, if you come through the school systems all the way to the 12th grade and not know how to do exponents or how to solve equations, uh, you know, I think I would think that a part of your education is missing. So, okay, all right. Anyways, now I already set the first one up, right? So today what we're gonna do is this. The difference between what we did yesterday and today is this. Yesterday when we dealt with these variables, notice, right? These are just variables. I never put a coefficient in there until today, okay? Because I want to save that for last, right? So now here you see coefficient, right? And then the other thing I want to practice some more on is negative exponents and zero exponents. So that's the goal today, all right? So here I laid this out already, right? 2a in parentheses to the third power. You can expand it like that. 2 times 2 times 2 is 8, not 6. A times A times A, it's A to the third. Now, the other way you can look at it is this. You can distribute this 3 to both the exponents of 2, which is 1, right? That's 2 to the first power, and so is this, A to the first power. So if you do that, right, you get 3 times 1 is the 3, so 2 to the third power times A, 1 times 3 to the third, right? 2 to the third power is 8, A to the third is A to the third. They both check out. All right, got that? Likewise, you can do the same thing with this. All right, I'll do it both ways for you guys. So here I'm gonna write this twice. So I got 6x to the third times 6x to the third. That's right, 36 x to the third times x to the third is x to the 6th. So you see how here, if you're still not 100% clear on the rules of exponents, I would like to think that it's typically this, at least for these topics, that you might be having a hard time understanding when you're supposed to multiply exponents and when you're supposed to add them, right? Now, so let me clarify that then. You're multiplying exponents, all right? Let me use a different color. Let's use green or something, right? You're multiplying exponents like this when there's a parentheses and this other exponent is outside the parentheses. So that therefore you're multiplying and distributing, right? It's likewise here. So let me show you, right? So this is 6 to the first power. So that's 6. So 2 times 1, so that's 6 to the second power, right? 2 times 1 is 2. That's multiplying, right? Here we got x. 2 times 3 is 6. So here 6, 36. X to the 6. Same thing. So the question is, when do we add the exponents, right? This is when you add the exponents. If you see something like this, right? Or a to the second times a to the fifth, right? In this case, there's nothing outside the parentheses. So I'm just gonna multiply these with the same base, which is the same thing as adding. Okay, so even though we're multiplying here, we're really adding the exponents. Whereas here, with this out here, with the exponent outside a parentheses, we're distributing. So therefore, we're multiplying, not adding. All right, so hopefully that clarified that up. I'm gonna erase this, okay? All right, so that said, let's try the next one. All right, so for this one, it's like the same thing. Again, if you prefer to write it all out, go for it. Okay, it's just that sometimes these numbers get so big that you're better off just, quote unquote, distributing like that, right? So here, x squared times x squared times x squared, that's times another x squared is x to the 8th. All right, y times y times y, that's y to the 4th. And that's it, there's nothing you can do. You can't say, well, I'm dividing, so I'm going to do 8 minus 4. You can't do that. These two bases, these two, this is a base of x, that's a base of y. You can't, right? They're not from the same family if you want to conceptualize it as such. Now, on the other end, if you say, well, Mr. Ring, what about, can you distribute with a fraction, with a bar like that? Of course you can, like that, right? You can still distribute. So what would that look like? Well, this would be x, and then that's 4 times 2, that's 8. That's really y to the first power, so 4 times 1 is 4. Again, like all the other distributive property questions, right? You can't forget about the other ones. So when you distribute, you got to make sure you distribute to all these values, right? Meaning the coefficient and variable, the two variables. Okay? All right. Now, why don't you try this one on your own? So if you want, press pause right now. Wow, it's already 7 minutes, huh? All right, press pause right now, and then I'll show you how to do it. All right, I'll go over it with you. So press pause right now. Okay, all right, and we're back. All right, let me just make sure I'm still recording. Okay, all right. So here, if you really, really want to, you could write the whole thing out. I would like to think that when I was your age, I would have written them out. Because I just feel like when I do this, I'm more certain as to what the answer is going to be. All right, so let's see. 2x times 2x, that's 2 times 2 times 2, that's 8. X times x times x is x to the 3rd. 3 times 3 now. 3 times 3 is 9, 9, 2 is 27. Y 2, 4, 6, y to the 6. Now I got to look at 8 over 27 if I can reduce that, because that's actually a fraction. So meaning if you don't reduce that, you could lose points. Okay? I think that's simplest form, so we're good here. Now, again, if you want to distribute it, right, you have to distribute it to the exponent of the 2 to the x to the first power, and then all those guys, right? So 3 to the first power here, and also the y to the second power here. You could do that, so 2 to the 3rd, right? So look, this is 2 to the 3rd power, x to the 3rd power, 3 to the 3rd power, y to the 6th power. Right, but nothing crazy. 2 to the 3rd power is 8, x to the 3rd, that's 27, y to the 6th. Yeah, same answer, okay? Now, don't get thrown off by the fact that, I don't know what the alphabet is, okay? It's not true. I just have to pick these letters, all right, from a worksheet. So look at this one now. Now we got a whole lot of things going on, right? So let me just use my magic pen to show you what I mean. First, we got a negative coefficient. We got ourselves 2 variables, and on top of that, one of those variables is a negative number, right? So we got a whole lot going on here. So what we're gonna do is this. we are going to solve it knowing that. All right, I just got an email. That's what that means. All right, so -4 now. There's nothing to simplify here. I don't know if you've noticed, right? Like there's nothing, I shouldn't say that. There's stuff to simplify. It's the opposite. There's nothing to operate on. There's no multiplication going on. There's no division, right? There's nothing to distribute with the parentheses, right? So this is just straight up like knowing if you know what you're supposed to be doing. Because I wouldn't be surprised if a lot of people see this and think, what is there to do, right? So think about it. What are the things that we have to do? There's really only one. We got to take care of this negative exponent. That's the only thing that we don't want. All right, so that means I'm going to keep my -4. I'll keep my x to the 5th, right? And y to the -2nd power, so let's take this out here. Y to the -2nd power means, right, I see the negative, which means immediately it's 1 over. So now the negative is gone because I do a 1 over, and then y to the 2nd power, which means this whole guy is multiplied by y, 1 over y to the 2nd power, which means this. By the way, that's still not good enough, because then you can bring this to the top, right? Because this is really over 1, so I got -4x to the 5th, and the lights just went off, y squared. That's it. Okay, got that? Now, I think what I'm going to do is this. I'm going to do 2 more here and then make the rest optional, all right? Because the people are coming in like a couple of minutes. So let me finish this, all right? So yeah, all right, yeah. Okay, all right, so here, now, this is tricky, right? Because now you got this huge negative number on the outside. So the question is this, right? Because even when I first saw this for like a split second, I thought, wait, what am I going to flip over? Don't even worry about that yet. Distribute first. Okay, so that means I got x to the -6 power, right? 2 times -3 is -6, and then I got y to the -3rd power, because this is really y to the 1st power. So far, so good, right? I'm just distributing. I'm not doing anything crazy. Now, what you realize is they're both no good. I don't want negative exponents for x nor y. So the shortcut would be this, right? If you don't want a negative, guess what? Put it at the bottom. Like put this guy at the bottom, make that a positive, right? Flip the y to upstairs, and now it'll be positive, and that's it. Yeah, that's it. It's that simple. Now, if you want to get technical and say, Mr. Ng, show me how you actually did it, watch this. If I look at the x to the -6 power, right? If I don't want that, what do I do? Yeah, I just do 1 over, right, x to the 6 divided by, right, y to the -3rd power, right? But you got to be careful. This isn't y to the -3rd power. This is actually 1 over y to the -3rd power. See that? So you actually have to flip this. You're divided by y to the -3rd power, but technically you're really doing this. Keep, right? And then now y to the 3rd power is 1 over y to the 3rd, right? So when you divide, what's the rule when you divide? Keep, change, flip. Look, 1 times y to the 3rd is y to the 3rd. X to the 6 times 1 is x to the 6. Look, same exact answer. Nothing crazy. Okay, you see that? All right, so that's why. So I'm proving it to you that this is okay. And so now I'm endorsing you guys to actually just take the shortcut. All right, now with that said, try F right now, press pause, and when you come back, I will go over it with you, and then that'll be it for today. Okay, so press pause right now. Okay, all right, and we're back. So now, I'm just gonna use the shortcut, okay? So now this is a game of like who to flip and who not to, right? So look, a to the -2nd power, so that goes to the bottom, right? So who's the only stays at the top? B to the 3rd. A goes to the bottom, so that's a square now instead of a to the -2nd power. You see c to the -4th power, that gotta bring it up. So I'm gonna bring it up after b because c comes after b, right? So c to the 4th power, that magically becomes positive. I also gotta bring d up, d to the 1st power. That's it. So if you want to make it nice and neat, b to the third, c to the fourth, d, right, over a squared. And that's it, okay? Wow, perfect timing. I actually got to go teach now. All right, good job, and thanks for watching. All right, continue so that you could see the optional bonus questions for these next 4, okay, where I'll go over it. Okay, all right, so talk to you later. Bye-bye. OMG, that was so good.